Hello dear colleagues, my name is Dmytro. I am an associate professor of the Department of Land Management, Geodesy and Cadastre of State Biotechnological University, and I would like to make a presentation which prepared with my colleagues from State Biotechnological University, Vytautas Magnus University, Lviv National Environmental University, and the topic of our presentation is the use of GIS technologies for geodetic monitoring. One of the directions of modern applied geodesy is deformation monitoring. This concept includes geodetic monitoring for subsidence and deformation of foundations as well as other important structural elements of buildings and structures. In addition to them, various industrial equipment can be objects of deformation monitoring. Deformation geodetic monitoring consists in regular tracking of deformation of building and other important structure by geodetic methods carried out with the aim of timely direction and prevention of the development of emergency situations. This type of engineering monitoring is an important link in construction as well as the system of state and department technical supervision. On 26th of April 1986, the largest man-made disaster in the history of mankind occurred, the explosion at the Chernobyl nuclear power plant. In a short time, from June to November 1986, a protective structure was erected over the destroyed fourth power unit of the Chernobyl nuclear power plant to protect the environment from further pollution. Today, this structure is known as shelter. Since the shelter facility was built within a short period and under extreme conditions, it does not comply with the rules and regulations for the design, construction, commissioning, and operation of either nuclear installation or radioactive waste management facilities or regular industrial buildings. Therefore, after its construction, the constant engineering and geodetic monitoring of the state of the entire complex of buildings and structure of the shelter facility became the key task. In addition to natural wear and tear, man-made factors also affect buildings' structure. Mechanical impact, abrasion, fatigue with repeating changing loads, corrosion of metal parts, structures, and elements, erosion, weathering of stone and concrete structures, etc. The mechanism and intensity of action of these processes are different. The degree of influence of the factors of each specific case may vary in intensity, but in each case, the main factor in extending the life of the building is the timely detection of the main damage and the defects of the building, as a result of which they are eliminated. The volume of engineering and geodetic observation of the shelter facility includes the regular determination of the high position of the settlement control marks on the foundation and the special position of the deformation marks located respectively in the plinths and on the upper tiers of the shelter facility. The sign installed on the foundation of building are placed on the transfer and longitudinal axis of at least 4 signs around the perimeter. They are installed on the end walls of the shelter facility according to the assembly diagram. In the place of temperature seams on both sides of them, control marks are installed. Observation at the point are performed in group of 4-5 direction to eliminate errors of focus change during one reception of observation due to a different distance and errors of closing the horizon. Angular measurements are carried out by high precision tachometers. Angles and lines are measured by the method of tunnel triangulation of the 1T discharge and tunnel trilateration of the 1T discharge respectively. Processing of the results is carried out using the Credo software complex, which allows performing in-camera processing of traditional geodetic measurements and post-processing results of satellite measurements of various accuracy classes in the selected coordinate system, with the possibility of considering the geoid model and a complex of reduction corrections. Moreover, various geodetic constructions are performed in the system. The Credo software product allows importing data from field measurements obtained from electronic tachometers within accepted formats. After entering the initial data and importing the measurement, the Credo system automatically recognizes and separates the data by types of measurements and form the network connection. The system preprocesses the measurements, calculates, considers the necessity, correction, and reduction, and calculates the preliminary coordinates of the points. Vector direction intersect to form a triangle of measurement error from different survey points under the same observation coordinate conditions. At the intersection point of the medians in the center of the observation point, where the coordinates of the x and y point are determined. Then the obtained results are entered into the table of observation according to the circle the geodetic monitoring was carried out. The use of GIS technologies allows for fast data processing, reduce the workload of the employee, and make it impossible to make mistakes during data processing and analysis. Since the beginning of the observation, the horizontal moment of 10 control marks of the northern wall of the shelter facility amount to 28 millimeters on average with the northern direction of the vector. The mark M18 has the maximum horizontal moment 34 millimeters from the beginning of observation. The average horizontal moment of the control marks M16 and M20 of the northwest corner from the beginning of the observation are 31 millimeter with the northern direction of the vector. At the same time, the maximum values of horizontal movement are 33 millimeters, the mark 16. The average horizontal moment of control marks M4 and the pin of the roof of the central hall from the beginning of observation is 19 millimeters with the northern direction of the vector. The maximum values of horizontal moment are 24 millimeters, mark 4. The control marks of the tower along the Z row received average horizontal moment from the beginning of the observation 8 millimeters with the north-west direction of the vector, and the marks of the P row got respectively 9 millimeters with the west direction of the vector. The control marks of beam B1 and B2 in row Z and P received average horizontal moment of 5 millimeters and 7 millimeters from the beginning of observation. Control marks M50 Z and M50P on the wall axis 50 have received a horizontal displacement of 5 millimeters and 13 millimeters from the initial observation. The horizontal displacement of the new control marks of the southern wall of the machine hall in row A from marks M302 to M312 during the observation period range from 2 millimeters to 10 millimeters. The horizontal displacement of this control mark on the western wall of the machine hall on axis 68 mark M301 has become 6 millimeters since the beginning of the observation. Analysis of the management magnitude of horizontal and vertical displacement of control marks includes that the process of deformation is taking place in the object and adjacent building and structures. Conclusion. The analysis of the horizontal and vertical movement of the control marks shows that the deformation process of the shelter object and its adjacent building and structure continues. For the analysis of movement of control marks over a year, operational limits of safe operation are established. Since geodetic measurements are equalized between observations some season over a year with minor fluctuation in measurements temperature. The obtained results will be used as input data for tracking the dynamics of movement, the stability of building structure, and taking timely measures to prevent the destruction of structure and forecasting emergency of the shelter facility as well as the adjacent buildings and structure. The values of moment of the control marks of the structure of the northern cascade wall for the annual period between the season observation of the same name do not exceed the permissible parameters of movement established by regular documents. The use of GIS technologies allow for fast data processing, reduce the workload on the employee, and makes it impossible to make mistakes during data processing and analysis. With the help of the Credo software complex, the processing of the result of geodetic surveying of monitoring points reduces the time burden, and which allows for a more in-depth analysis of deformation process, which in turn makes it possible to timely identify critical indicators, if any, during data analysis. This concludes my report. Thank you for your attention.